Every night, without thinking much about it, billions of people glance up at the moon and see the same familiar object that has watched over Earth for as long as human history can remember. It has inspired poets, guided sailors across oceans, influenced calendars, and lit up the night sky for countless generations. We often assume it will always be there, hanging above us exactly as it is today. But what if that isn't true? What if, right now, while you're watching this video, the moon is already beginning a slow goodbye that started billions of years ago? The truth is both fascinating and unsettling. The moon is moving away from Earth, and scientists have confirmed it. Every year, it drifts approximately 3.8 centimeters farther from our planet. That may sound insignificant, less than the growth of your fingernails, but over millions and billions of years, the effect becomes enormous. In fact, laser reflectors left on the lunar surface by Apollo astronauts have allowed scientists to measure this movement with incredible precision. The moon is slowly escaping our grasp. To understand why this is happening, we need to travel back more than 4.5 billion years to a time when Earth was a violent, molten world. According to the leading scientific theory, a Mars-sized object crashed into the young Earth with unimaginable force. The collision blasted vast amounts of debris into space, and over time that debris merged together to form the moon. At first, the moon was much closer than it is today. Some estimates suggest it appeared several times larger in the sky than it does now. Its gravitational pull was stronger, tides were more dramatic, and Earth itself rotated much faster than it does today. But something remarkable began happening. As Earth spun on its axis, the moon's gravity pulled on our oceans, creating tides. Those tides didn't just affect Earth, they also affected the moon. The tidal bulges in Earth's oceans are slightly ahead of the moon because our planet rotates faster than the moon orbits us. This creates a gravitational interaction that transfers energy from Earth to the moon. Earth loses a tiny amount of rotational energy, causing our days to become slightly longer, while the moon gains energy and moves into a higher orbit. It's a cosmic exchange that has been occurring for billions of years. The result is a slow but relentless separation between Earth and its closest companion. Today, the moon sits roughly 384,400 kilometers away, but every year that distance grows. Fortunately, nothing dramatic will happen anytime soon. Humanity will not wake up tomorrow to find the moon gone. Yet the long-term consequences reveal just how important the moon truly is. Most people know that the moon controls the tides, but few realize how deeply those tides influence life on Earth. Entire marine ecosystems depend on tidal cycles. Countless species use them for feeding, migration, and reproduction. Without the moon's gravitational pull, tides would become far weaker, disrupting ecosystems that have evolved for millions of years. Coastal regions would change. Ocean circulation patterns could shift. And because ocean currents help distribute heat around the planet, even global climate systems could be affected. But the moon's role goes far beyond the oceans. One of its most important jobs is stabilizing Earth's axial tilt. Right now, our planet tilts at about 23.5 degrees, creating the seasons we experience every year. The moon acts like a giant stabilizer, preventing Earth's axis from wobbling excessively. Without it, the tilt could vary dramatically over long periods. Imagine a world where some regions experience decades of extreme heat, followed by centuries of deep freeze. Scientists believe that without the moon's stabilizing influence, Earth's climate could become far more chaotic and unpredictable. The moon also affects the length of our day. Billions of years ago, a day on Earth lasted only a few hours. Thanks to the moon's tidal braking effect, Earth's rotation has gradually slowed. If the moon were gone, this process would change, altering the rhythm of our planet in ways that would affect weather patterns, ecosystems, and potentially life itself. Then comes the question that sounds like science fiction, but is rooted in real science. What if the moon eventually escaped Earth's gravity entirely? The answer is both reassuring and terrifying. Reassuring because it won't happen for billions of years. Terrifying because if it did, Earth would become a fundamentally different world. Nights would be darker. Tides would weaken dramatically. Climate stability would decline. Many species that rely on lunar cycles would struggle to adapt. Some scientists even suggest that Earth's vulnerability to certain asteroid trajectories could increase without the moon's gravitational influence. While the moon is not a perfect shield, it has absorbed countless impacts throughout its history, impacts that otherwise might have threatened Earth. Yet perhaps the most fascinating part of this story isn't the future. It's what the moon reveals about the universe itself. The fact that two celestial bodies can remain locked in a gravitational dance for billions of years, while slowly drifting apart, demonstrates the incredible complexity of cosmic mechanics. Every full moon you see is part of a process that began before complex life existed on Earth. Every lunar eclipse, every tide, every moonlit night is connected to forces that have shaped our world since the dawn of the solar system. And although the moon is moving away, it remains one of the most important reasons Earth is the planet we know today. Without it, life might have evolved differently, or perhaps not at all. The next time you step outside and see the moon rising above the horizon, remember that you're looking at more than a bright object in the sky. You're looking at Earth's oldest companion, a silent guardian that has influenced oceans, climate, and life itself for billions of years. It's slowly drifting away, centimeter by centimeter, year after year, carrying with it clues about our past and warnings about our distant future. The separation is so slow that no human will ever notice it, but in the grand timeline of the universe, the farewell has already begun. And perhaps the most incredible realization of all is that the fate of our planet has always been tied to that pale white sphere, hanging silently above our heads, reminding us that even the closest relationships in the cosmos can change with time.